Hello. In this video, we're going to go ahead and look at an application. In fact, it is the same application that we just saw in the previous video. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. Find the instantaneous velocity at 2 seconds. Now, notice I said it's the same one. It's just that with the other one, we wanted the instantaneous velocity at 4 seconds. And I don't care about the average rate of change either. So in this one, I just want you to figure out what is the instantaneous velocity at 2 seconds. So I'm going to go ahead and give you some time here. And I'll give you 5 seconds in case you haven't actually already done this, like I kind of suggested in the last video. Okay, now, what I want to do is I want to discuss why we're saying velocity is the average rate of change or the instantaneous rate of change of position. Now, think of the units. Distance would be feet. Velocity, but I don't really like the word velocity. I do like the word speed better, would be feet in distance divided by time. So it's distance over time is what speed is. So feet per second. Now, if you did this one more time, if you found the average rate of change of speed, that would actually give you acceleration, which would give you feet per second squared. Now, that's just in this particular situation. So it's a distance, and then speed is distance over time, and then acceleration would be distance over time squared. So distance per square time, basically. Now, the reason that we have this is kind of from the dirt formula. Distance equals speed times time, or the dist formula, if you will, in this case. Notice that if I solve for speed, I can divide by time, so speed is just distance over time. And that's actually what we have from here. But if you look at the average rate of change formula, it is the distance of some a value, whatever a is, plus h minus s of a all over h. Now, this right here is just telling me the change in the distance. It's how far it goes. That's what this distance here represents. And this h is how long that took. That's for the average rate of change. So that's actually the time there. That's what this h is representing. It's a change in time. Okay, so really, instead of having d over t, it should really look like this. The average speed would be the delta d over delta t. And this little delta is the Greek letter delta. Now, it just means change in whatever it is that you're talking about. In mathematics, that's what we use this capital delta for. And the reason that we use it is because, well, frankly, we are lazy in mathematics. Because instead of doing delta d over delta t, what we would do instead is d2 minus d1 over t2 minus t1. And oh, look, that again looks like the slope formula. So there you go. That is why, if you're given distance, then the average rate of change is the speed. So if you want to know speed, you need to look at the average rate of change of distance. That's really what we're looking at here. Now, if we want to look at the instantaneous speed or velocity, I prefer speed, but velocity is what is said in this problem, then you need to look at the instantaneous rate of change, which is taking the average rate of change and taking the limit as h goes to 0. And that's pretty much it. Now, what that tells me is that the instantaneous velocity here would be the limit as h goes to 0 of s of, in this case, 2 plus h minus s of 2 and then all over h. Now notice that this a value is wherever it is that we're evaluating at. In this case, 2 seconds. From the previous video, or if you just want to figure out what s of 2 is, you can just plug in 2. So 2 squared is 4, 4 times 2 is 8, minus 5 times 2 is negative 10, 8 minus 10 is negative 2, negative 2 plus 40 is 38. So s of 2 equals 38. That's what we're going to replace this s of 2 with. The question becomes, though, what is s of 2 plus h? Well, let's figure that out. We want to look at s. Yeah, I don't want to put that there. S of 2 plus h. That will give me 2 times 2 plus h squared minus 5 times 2 plus h plus 40. By the way, I apologize for my h's. They are terrible, I know, but I will try to make them legible. I'll probably have to rewrite many of them. Anyway, we need to simplify this. That's all you do to find s of 2 plus h. Notice you do not want to distribute the 2 first. All you want to do first is to square this binomial. To do that, first write that 2 and then a couple things of parentheses. Do you remember how to square a binomial without having to FOIL it? If you do, try to do it now. It's actually very helpful if you can do this. Okay, so first we're going to square the 2, which gives us 4. Then we're going to square the h, which gives us h squared. Now that's always positive, because when you square something, it's always positive. The question is what goes here in the middle? Well, to figure that out, you multiply these two things together. That gives you 2h, and then you double the coefficient, which gives us 4h. So that will be plus 4h right there. And that's how you square a binomial. Now, what I just did probably seems a little bit weird, and you're probably still not used to it, but I do want you to try to work with it this way. It will help, I promise. Okay, now just distribute the negative 5, making that negative 10 minus 5h plus 40. And at this point, distribute the 2, which gives us 8 plus 8h plus 2h squared, and then minus 10 minus 5h plus 40. And again, just combine like terms. And whenever we combine like terms, I'm going to start out with the highest degree, which is 2h squared. There are no other h squareds, so that's it. So I've used that. Now let's look at the h's. We have 8h, negative 5h. 8 minus 5 is negative 3, so it's a positive 3. Positive 3h. Now 8 minus 10 is negative 2. Negative 2 plus 40 is 38. And again, it's no coincidence that this is the same as this. Awesome. Just plug this in for this right here and plug 38 in for that and see what we get. That's going to give us the limit as h goes to 0 of 2h squared plus 3h plus 38 minus s of 2, which is 38. And then all over h. Awesome. But here's the thing. 38 and 38 cancel each other, right? They're gone. Now, if you look in the numerator, there's an h in common with both of those terms. There will always be for this type of question. So what we want to do is we want to factor out that common factor of h. Now, that doesn't mean that that will always be the only common factor, but that's the only one we care about. So we're going to factor out the h, And what's left over is 2h plus 3. Now notice that in the denominator we still have h. Awesome. And now notice that because that's a factor and that's a factor, they're factors of both numerator and denominator, they will cancel each other, leaving you with just a 1 for each one of those. But if it's just a 1, you don't really write it. So then we just have the limit as h goes to 0 of 2h plus 3. Plug in the 0 for the h, because that's just a polynomial now, which gives us 2 times 0 plus 3, and that gives us 3. Good. Now, that tells me that the instantaneous velocity is 3, and remember the units here are feet per second. Awesome. And there you go. Now, I do want to remind you of a couple of things. If you remember from the previous question, the instantaneous velocity, I'm just going to do it, v sub 4 was 11. And for this one, we just figured out that v sub 2, the velocity at 2 seconds, is 3. Notice that if you take the average of those two, 11 plus 3 over 2 is going to be 14 over 2, which is 7, which is exactly what we figured out our average rate of change to be in the previous question. That's not a coincidence. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.